Hi, welcome to part 3 on my Toolpost grinder. This time the task on hand is to make a mount for the motor. The motor will ride on this rod and has to be adjusted in that direction to tension the belt. So what I decided to do is I'm going to drill and ream this piece of leaded steel to 20 millimeters. Then I'm going to weld a piece on, this piece of flat that will be around here, and that will get the hole pattern to accept the motor. After that, the bushing will be slit and we'll get a clamping screw, a tangential clamping screw, so it can be placed on the rod and locked. There will also be some way of hindering it to rotate on the rod. Maybe I will machine a slot into the rod and put a anti-rotation pin into the bushing, but we will see. For now I'm going to drill and ream this piece to go over the rod. Okay, we're going to chuck this piece up, center bore it, center drill it, and drill to 18 millimeters or 90 millimeters, and then ream to 20 millimeters. I'm going for a 5mm pilot drill. With this refluted drill to open up the hole to 60mm, then we run a boring bar through it to open it up to 90mm, and then we will ream it. These drills are strictly for opening up holes, not for drilling into solid material. Okay, I'm using this shop-made 12mm boring bar with a round carbide insert on front to open up the bore to about 19mm, so I have enough material left for reaming. Just take a measurement. And we're at 19.1. I will go another 1/10 of a millimeter to give it a bit nicer surface. Now we need a chamfer to give the reamer a good start. I'm again using this tool Tom Lipton showed in one of his videos. It's a external chamfering tool, left and right handed, and it can also do on this back edge internal chamfers. I know that this reamer is slightly reaming oversized, but as we're just making a bushing with a clamping feature, that's not a problem. That's it. Okay, now as we have our part bored to 20 millimeters, we flip it around and turn it to length. At the moment it has 35.2 millimeters and we shoot for 35 millimeters. I'm bringing in my dial indicator for the bed slide. I'm touching off with the tool, zero my dial. Go in, 0.2 millimeters, clamp my bed slide and take a facing cut. Moving that out of the way, putting on an internal chamfer. And also on the outside. There we go. Done deal on the bushing. A nice bushing that should be about 35 millimeters long. Yeah, hit it pretty good. This will be our clamping boss. I'm just going to turn it to length, drill it, tap it 5 millimeters, and then drill it for screw clearance half the way through. Okay, we need a circular cutout in this bushing where we can weld this clamping piece in. And I'm just going to plunge down with a 10mm end mill, as this is 10mm round stock. Clamp it down. I already have a 10mm end mill that's pretty beaten up in a end mill holder, and I'm going to roughly center on the workpiece and plunge down. And as there is really no precision required for this application, I'm just centering it with a scale. And I'm just plunging down with the quill. Okay, that's the cutout I need to weld this piece in. Okay, I already welded the piece in place. I just have to go around on the ends on both sides just to close it up. Okay, here we have the brackets so far. We got a not too ugly weld all around the clamping screw boss, and later we will slit it in that direction all the way through. So with a screw in this boss here we can clamp this bushing. Okay, this is my piece of code roll that will be the motor mounting blade. One end is sheared off by the manufacturer. That's pretty rough, and the other side is sawn. I will square up both sides. I just changed my mind. I will just square up one edge, drill the hole pattern, and then look what I do with the other side. And my parallels don't stop to fall over. Okay, I'm just clamping it on the parallels, sprout of the vise to the side, clamp it down. Give it a light tap. Sounds like there's something under it. Sounds like a chip. That sounds better. That too. Now centering between the jaws. This again is a 18mm annular cutter, and after that we will open up the hole to 28mm, 25. And I'm on the wrong pulley. I need to slow it down, because I run this machine with a variable frequency drive, and I had it on a higher pulley setting for high speeds. There I have no torque on the lower speeds, so change over the pulley and go again. Okay, I wrote a short program, so the machine cuts a spiral down through the part with a diameter of 25mm. Okay, I just machined out a notch where the motor plate will be welded in. Okay, I mounted the motor plate to the motor with one screw, just to test fit. This is my bracket with the cutout, and now we're going to weld them together like this with a big fillet weld in here and a small one on the inside. That should be plenty strong enough to hold them all together. And then I'm able to slide that whole motor assembly onto this rod. Okay, I marked the center where my clamp will go with soapstone, and I'm just going to hold it by hand and tack it in place. Just to check if I'm in the center. Yeah, good enough. This is my first pass. It doesn't look to a second pass over this one to give it a bit more rigidity. And I will also do a fillet weld on the inside. this is the bracket after finished welding, and now I'm going to machine a light chamfer on this and this side and on the top edge, and also going to slit it in that direction. Okay, there we go. We slid the clamp on bushing for the motor mount, and as before I put a piece of brass in it to prevent pinching on the blade. And this time it seems that the stresses after relieving caused the piece in the bore to bind. So if the piece of brass wouldn't be there, my saw blade might be shattered right now. Okay, this is my motor clamp now, welded together, slit, and ready to be tested. There is a M5 by 22 screw for clamping, and the motor is here. Here, and we put in 4 M4 by 12 screws. Okay, that fits together. Now we take our motor, put it on this rod, and we can clamp it wherever we want using the screw down here. So there we go. That's the setup so far. Two main things are left to be done. First is to machine a slot into this rod and put a anti-rotation pin into this clamp bushing, and the other one is to machine a pulley for this 4mm polyurethane. We will weld a endless belt for this Toolpost grinder out of it. So that's it for now. Thank you for watching and hope you enjoyed.